Hey there, fellow members of the concrete construction industry. Before we get started today, I want to take a moment to address something important. As professionals in this industry, we understand the challenges we face and the constant need for up-to-date knowledge and valuable insights. That's why we're here, providing you with a podcast that caters specifically to our community. But let's be real. Producing the show requires a significant investment of time, effort, and resources, and that's where we need your support. We're embracing the value for value model, which means we're reaching out to you, our dedicated listeners, to help us sustain and enhance the podcast. Think about the value you gain from our episodes, the practical tips, the industry trends, and the expert interviews. We want to keep delivering that value to you, but we can't do it alone. Instead of interrupting your listening experience with ads or sponsorships, we're relying on your generosity. If you find value in what we do, we kindly ask you to contribute what you can. Your support helps us continue producing high-quality episodes that address the specific challenges and interests of our concrete construction community, from supporting the cost of equipment and hosting fees to bringing in industry experts for exclusive interviews. Your contribution makes it all possible. We understand that every business and individual has different capacities to give, and no amount is too small. Whether it's a one-time donation or a recurring contribution, we appreciate your commitment. By supporting us, you become an essential part of our mission to provide valuable content tailored to our industry's needs. Together, we can elevate our professional knowledge and expertise. So please take a moment to visit our website, concretelogicpodcast.com, where you'll find a donation page that makes supporting us quick and easy. Thank you for being an integral part of our concrete construction community. With your support, we'll continue to build a brighter future for our industry. What is the most used man-made material on Earth? You guessed right. It's concrete. Look around. It's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. Welcome to another episode of the Concrete Logic podcast, and I have another returning guest this week, Tyler Ley from Oklahoma State. I was thinking the other day, I think we're about the same age, but do you remember the guys that used to tour around? I think they toured around the United States, the N1 basketball guys, and they had these really cool names and everything. I don't.
A little bit.
Anyways, there's this one guy called the Professor.
Nice.
He was really good at dribbling and do it behind his back and everything. And when I think of the Professor in concrete, you're the guy.
Thanks, man.
Yeah. So I know you like the Concrete Freak and that stuff on YouTube and everything. But when I think of the Professor, that's Tyler Ley.
Thank you, Seth. That's an honor, man. I am a professor. We're not all created equal, and we don't all put you to sleep. We do our best to try to keep you awake and help people move our industry forward.
Yeah. So, I've told folks before, you need to check out Tyler's YouTube videos. They're very entertaining, and they also are, you learn something obviously too. Tyler teaches for a living, so that's pretty awesome the way he does things on YouTube. But Tyler, I reached out to you because I was on your YouTube channel and you had a thing about a new water cement ratio test. So I wanted to bring you on so you could talk about it because I was a little bit confused about how it works. But first, can we talk about the water cement ratio? Why is it important? The origins of it all?
Yeah. Water cement ratio is the amount of water in your concrete divided by the amount of cementitious. So cement, SCMs, could be fly ash, could be slag, could be something like that. Basically the water divided by the binder. And why that matters is that the more water you add, the more you're diluting your binder in your mix, the stuff that glues everything together, the stuff that gives you strength, the stuff that gives you low permeability concrete. So a lot of people would tell you, and a lot of test data, a lot of just knowledgeable folks will just tell you that is the most important parameter in concrete. And that as more water is added to the concrete, it may make it more workable in the moment, but it may decrease, or it will decrease other properties. And there are times when we need really consistent concrete, really high performance concrete, really to make sure that we get the recipe correct. And right now, there's not a great tool to do that. So you can do a moisture cook off on your ready mix truck, on your aggregates, right? Find your moisture content of your coarse and moisture content of your sand. And I hope most people are correcting for that or watching for that and changing for that. That's a key quality step. But then there's just other ways that water finds its way into the concrete mixture. Sometimes there's some extra water in the drum. Sometimes there's the moisture corrections are off. Sometimes at the wash rack, some water gets added. Sometimes on the job site, the people just decide that it's not what they want. And they want to bring it to whatever they think they want in the moment. If there's water available to be added, those aren't problems. Okay. They're not. But if there's not, that can become an issue. And on certain jobs, we just want really consistent concrete. So like a slab on grade, a large industrial floor slab where the concrete finisher is all about, they want uniform. They want to control the set time. They don't want one thing setting and another thing not setting. They want to control their finishing. They don't want one part wet and another part dry. And so water is truly the one variable that would help out with that. And we've known this a long time. TC Powers figured this out a long time ago. One of my heroes of concrete, right? He figured this out a long time ago, and we've known it. It's in all the textbooks. I hope everyone's learned it before or remembers hearing about it. It's just, we've never had a tool to measure it. And when you can't measure something, then you can't really know where it's at. You can't really control it. You can't really get it to where you want it to go. It's just it's challenging. It's really challenging. And so I've known about this for a long time. Ever since I was first learning about concrete, my advisor, my teachers would tell us, yeah, water cement ratio is the most important thing out there. No way to measure it. It's like, what? Holy cow. There's got to be some way. Some people will tell you the slump test measures it. No, the slump test is cool. It's simple. It's easy. I think the slump test tells you about consistency, but I don't think the slump test tells you how much water's in your concrete. There's a lot of things that can change the slump test. Okay. Then some people will say, no, those strength tests, cylinders. There's a lot of things that impact cylinder strength, a whole bunch of stuff. And I would say one of the biggest ones out there is how people handle cylinders. Okay. In our industry, we don't always do the best job of keeping track of those cylinders, handling the way they're supposed to. And that's tough because that's people's pay that's based on that. And that's challenging. But water can impact slump. It can. And water can definitely impact strength. It can. But I just think there's a value out there, or we should be focusing on measuring things consistently and things that are helpful. And I think the Phoenix helps that with water. Now, some of your listeners, some of your really astute listeners out there might say, oh, microwave oven test. And there's this test that take concrete and you cook it in a microwave and you basically figure out how much water's inside of it. And people have tried that test for a long time. And the problem is that it just doesn't use a large volume. Okay. That test just does not use a large volume of concrete. And it requires a bunch of labor because a person has to take that, break it up, cook it again, break it up, cook it again, because you got to break those particles apart. We actually started with the microwave oven test, took it totally apart and put it totally back together again in a way that's simple and easy and low amount of labor and gives you really consistent results because it uses a lot more material and that's the Phoenix. So this has been like, boy, 4 or 5 years of work. And I think we were talking before and you were like, wow, is this thing new? I haven't been talking about it before, but it's not new to me. It's been cooking a while. Right.
Pun.
But
Yeah.
anyway, the Phoenix, the way it works is you fill up a mold that's a 6-inch diameter by 4-inch deep mold and of concrete. You have to know the absorption capacity of the aggregates. You have to know your mix design. Okay. You have to know the specific gravity of the aggregates. And then you can't do a mix design if you don't know the absorption and the specific gravity. So those are things that people know. Okay. And you got to know the batch ticket information. And basically you make a certain amount of concrete, you put it in a pan, you make it pretty thin. You put it in this specially designed oven that provides heat from the top and the bottom. Okay. Really high amount of heat. And that's why it's called the Phoenix, right? Because it's hot, right? And then you take it out after 15 minutes and you weigh it. And there's an app that helps you do all the calculations. And then you put it back in the oven for another, I think it's 2 minutes. And then you take it out and check it again just to make sure that you got the water out of the concrete. And if you didn't, you'd put it back in and take it back out. You're just basically looking where it doesn't change mass anymore as you do it. And you remove all the water from the cement paste and all the water from the aggregates. And then we use math to see how much water would have been in the aggregates. Okay. And that's been published and talked about before. And then you say, hey, this is how much water I have. And then you trust the batch ticket to figure out how much cement I would have. And then you get the water cement ratio. So truly the test measures just the water content. And we do some calculations to get the water cement ratio.
So you're starting with the wet concrete that has the water in it, and then you end up with the concrete with no water in it, and you're taking the difference of the weight, and that's how much water was in that mix, and you're verifying that. Is that
Yeah, that's
correct?
right. And it took a lot of, that's dead on. It took us a lot of work though to figure out how to do that in a rapid manner. Okay. And how to get a large enough sample size that we could get a consistent measurement out of it. Because if you have too little material, it's just not consistent. It's not representative of your sample. And there's also some importance in sampling. Okay. Being very honest, you have to be careful that you sample, you don't just sample some that doesn't represent the concrete, if that makes any sense. And we're actually working on ways now, we got to make that part of the test, to whether maybe you'd run like a unit weight and then compare it to the weight of that little small amount of concrete and compare and make sure that they match, or maybe just doing several measurements of those little dosages of concrete just to figure out, not necessarily cooking them all, but just measuring them wet to make sure that, oh yeah, this is a representative sample of the concrete. That's stuff that we're working through right now. But that's a great thing about these things. They're always evolving. And as you go out and give presentations, you get feedback from people and you make videos and I love reading my comments that everyone writes in and responding back to them. And so it all gives you different viewpoints and things that you didn't notice before. So it's awesome. We can make it better.
Yeah. So it's more complicated than just not taking, like, I reached out to you because I was trying to figure out how you do this out in the field. I saw the videos and everything, and I could see it being done in the lab very easily and everything. So you would mix your batch in the lab and then do that whole process that you just talked about. But if you're out in the field, as of right now, I know it's changing a bit. How do you see that process go versus what happens in the field right now when we take out concrete that comes out of the chute, and then we do our slump test, and then we do our air test and all that good stuff? How does the Phoenix fit in that process?
Good question. Let me just talk about how people are implementing it now. Okay. Because there's about 15 to 20 so people that are out there using it pretty much in the field. When they use it, they're pretty much using it in the field. certain places will use the equipment at the ready mix plant. And after the ready mix truck is done batching and mixing, they'll discharge a wheelbarrow of concrete. They'll send the truck on its way. They'll run the Phoenix on it while it's on the road. Okay.
Mm.
And once it gets there, then they'll let them know, how much water they can add. And then it's a great feedback for the batch plant itself. Okay. And a lot of contractors are extremely interested in that because it helps dial in your water before anything leaves the plant. You know what I mean? It helps get it going and get it right. And it gives a lot of feedback to the ready mix producer.
Yeah.
Now, there's other people that are bringing things like trailers, or there's one group in Utah that's using a box truck, okay, where they put the Phoenix in the back of the box truck, or they put the Phoenix in a trailer and they roll it out to the job site and they run it off a generator, and they don't treat it any different than they would with slump strength and air. Like when you get your wheelbarrow of material, the first sample that they make is for the Phoenix because it's going to take a little bit of time to run it. So they make a cylinder, like a little 6-inch by 4-inch cylinder. They'll start the Phoenix up and then they'll go and run their other quality control tests. Okay. And they let the Phoenix sit there and cook as they do everything else. Once they're done with it, they come back and check the Phoenix. They run the number and then they, go from there. So that's been done, or that is being done by several different people in the field now. And they don't do it on every project. Okay. This is more of a when you need it type thing. Okay. When you really got to make sure that we get this right type thing. And Minnesota DOT, that they're running it in kind of a trailer type thing as well. And then there's my group and some other people have done the exact same thing without the trailer. Okay. So they roll out on the back of a pickup truck or put a metal table down. Okay. You put the Phoenix on top of that, you plug it in, and you run it from there, just like that. And so again, the wheelbarrow comes up, they reconstitute it, remix it, make sure, somewhat uniform. Take your first couple scoops to run the Phoenix, get that going, and then you run all your other stuff as far as slump, strength, and air from there. Yeah. And I think we're going to be at the World of Concrete this year running the Phoenix, and it'll be outside where everyone can see it. But yeah, if you have any other questions about that or concerns, it'd be good to hear your feedback. I know you're a field guy that lives and breathes this stuff every day.
Not as much as I used to. Now I just go find the work. But I do. One thing that popped in my head, just a regular old 120 volt plug, right? Power wise.
No, it's a 210. It uses a little bit higher wattage. And so if you're going to do it in the lab and the plant, that's easy to get. In the field, you need a certain generator, but not that expensive generator, and you can get it off Amazon. It is good to have one with clean power, okay, because it has a controller on the Phoenix. And so if you just pick any old generator, it may or may not work because the power may not be clean enough, but I can help you get some that has super clean power that seems to work every time. So
yeah, I like the first version you said, or where you test the truck at the ready mix plant and then they drive. Because what I popped in my head was, okay, you withhold water when you're setting up your truck, and then you send the truck on, and then by the time it gets there, because 15 minutes is like a perfect distance away from a job. So by the time it gets there, they know how much water they can add by using the Phoenix. So I see that scenario working out very well. Do you test the folks that are using it? Are they testing every truck or every other? How often are they testing it?
That's a good question. So it really depends on what kind of consistency you want to dial in. And it really depends on where you start out. What most plants are doing that are using this, they usually test the first load of the day. Okay. And then they'll definitely test if there's a big change. Okay. So if they get a new delivery of aggregates in, if something's off, right? Anytime the batch person has a concern, I'm not so sure about this, then that's a great time to do it. And that's actually what a lot of people have said is they just feel so much more confident in their concrete going out because they've got the Phoenix and they've run the test and they just feel better about it. You know what I mean? That it's going out. But usually the first truck of the day, maybe the first 2 or 3 trucks of the day to make sure you get everything dialed in, depending on how important the mix is. And then after that, they can back into what their moisture content of their system is. Does that make sense what I'm saying, Seth?
Yeah.
Because you think you know what you have, right? But sometimes you don't really know what you have until you start making concrete with it.
Yeah. No. Yeah. Like you said, water can be trapped in so many different places around a ready mix plant or in the truck it makes total sense to me. So you said it sounds like concrete contractors are using it, ready mix suppliers are using it, and DOT is using it. Is that correct? Or
Yep, that's right.
Third party inspection kind of scenario. Is that?
Yep. That's how everyone's using it.
Okay. And as far as the cost, is it expensive? I know we wouldn't do this test if we were doing like a residential driveway or sidewalk or something. This would be like you're doing like a giant Amazon, or maybe you're doing a data center, or you're doing a multi-level high-rise kind of project. It would make a lot of sense to do this level of quality control because that's what this is. This is taking quality control to another level. As far as the cost, is it expensive?
Yeah. It's not a couple $100, right? It's about $17,000 and that's all in. That's everything you need to run the test. If you have a generator, then that's great. If not, you may have to buy one of these other ones or whatever. And that's not for a trailer or anything like that. But I think a lot of people probably won't have to have a trailer to run it. And some people say, man, that's expensive. And I get that. That's not what people are used to spending when it comes to concrete quality control. But I like to say back, expensive compared to what? Because if you're doing one of those high important projects and you have a bad day, you know what I mean? You know what I'm talking about, right? A bad day, like where it starts out bad, you're chasing your tail throughout. You think you fix it, but then you don't. You wonder about how many trucks made it to get in the forms. Are they going to get strength? Are they not? What's going to happen? Those aren't good days. When I was a contractor, those are not good days. Okay. Those are not good days. And to have a tool out there to help you with that is extremely valuable. Have a tool to make you feel confident, to even show, look, I'm stepping up. I'm doing more than what the normal is. Like here, I can show you. And also, if you compare it to other equipment that's out there, concrete compression machines, it's actually less expensive than those. And then if you have any asphalt listeners out there, they have something called an asphalt ignition furnace. Okay. And it measures the binder content inside asphalt. And this is less expensive, in the same ballpark as that equipment. So it's not like you always have to think compared to what, right? It's more expensive than probably what people are used to doing, but I think it can bring a lot of value in certain circumstances. You know what I mean? And I think between you and me, I think there's going to have a lot of changes in our industry coming up. And I think there's going to be a lot more challenges in our industry coming up. And the people that can step up and make that happen, as in still deliver value and quality in the face of all those challenges, they're going to be rewarded heavily. They're going to be the ones that get repeat work. They're going to be the ones that people are going to say, I don't care what your cost is, because I want to know it's right. This is concrete. This thing lasts generations, baby. Okay. This is stuff that when we do jobs, our kids, our grandkids, our neighbors, that's what we're doing for them, right? We're giving them a gift to the future. And this idea that the cheapest, fastest, I'm not sure is always going to be the winner in the future. Does that make sense? I'm not saying every job, my friend.
Yeah.
I'm not
No,
saying every job, but I'm saying
think
there's people out there that would be willing to pay to know it's right.
you're not buying one of these for every job too, right?
Oh, no.
You buy one of these, and it should last multiple jobs, right?
Yeah. This thing could last you 10 years. I mean, this thing is going to make you money.
Yeah.
Just the release of stress has been immense for the people in the concrete industry that have used this equipment. It's been really valuable for them. And that's what I keep hearing from them again and again. It's like, when I have the Phoenix, I know I can do it right. I know I can get it dialed in. And I'm not saying you have to have it. I'm not. We've made concrete for a long time without it. I'm just saying that's the kind of stuff that it provides.
Yeah, no, when I first saw it and I was going through your video and then checking out your website on concretephoenix.com, you look at this thing, you're like, why haven't we done this already? Isn't there something else? But I know we talked about the microwave thing, but that sounds like way too much work. And it seems like something that honestly we should have thought a while ago. So it's a pretty cool machine. And I think what you're getting at, the challenges that we're having, is the changes in cement is one of them. And it's the feedback I'm hearing out in the field is it reacts to the water differently. It has a different water desire than type 1-2 cement. So I think having a test like this is crossing off another list of possibility of problems that you may be having out in the field. If you do have one of those bad days, like you were saying earlier, there's just a list of things that could have happened, and you're just going back and you're trying to figure out where it is. And if you have something like this, that should cross out your water cement ratio possible of issues.
Yeah. No, I agree. I think it's valuable.
You're going to agree. You're a little biased.
But I'll tell you this, I've used it in my lab on every single mix. Okay.
Right.
And I do a lot. We mix every day in our lab. Every single day we're making concrete. And I'm a researcher. Okay. I'm different. I'm an odd duck. I get it. But I've seen the power of what it can do, because we try to do our best to batch consistent concrete every day, and we don't always get it right. And I was shocked at when sometimes the things that would happen to make it not right. You know what I mean? And so it's just been valuable. But I am biased because it's my baby. You know what I mean? So I am biased. I love my baby.
Yeah. Oh, it's cool. Yeah. You were talking about how we use the slump to check water cement ratio earlier. And there's just so many things out there, even new things that you can do to make that slump look however you want to now.
I totally agree. Admixtures and a lot of different things out there. And our friends in the engineering specifying, it doesn't have to be engineers, it can be architects too. Our friends in the specifying community I think they have this belief that the slump tells them more than they think they do. Okay. And I'm an engineer and I teach engineers, and I'm trying to change the younger generation and teach them out there, but we need to help get that information out there to people, because slump's a means and method as far as I'm concerned. Slump is how flowable the concrete is, as far as I'm concerned. Okay. And people shouldn't be telling us that our can't be too high or our slump can't be too low. If they want to give us some kind of consistency measure on the slump, okay, maybe, but I still think in the end, I think they need to stay out of that business. But they'll say all the time, but I don't have any other control over the water. And I'm like, you're just delusional if you think you got control over the water now with the slump test. But so this is a way to measure more what's important. So maybe it could help with that, because people shouldn't be rejected for slump. I don't think shouldn't even really be judged on slump.
Yeah, no, it's To me, it's a workability thing. So if you're doing slip form, you want a certain slump. If you're pumping concrete, you want a
Yep,
certain slump.
for sure.
So I don't understand why everybody else is getting into that. And then the whole just check the slump at the end of the truck versus the end of the hose and all that other craziness and the maximins. And man, we waste a lot of time with the slump.
I agree.
We got a few more minutes here, Tyler. I always like to check in now that we've talked about the Phoenix, and I'll make sure we'll share that info on there. Is there anything else you've been working on? I always like to check in to see what you guys are up to.
Yeah, we've got a really big FAA project right now. So if people do airfield pavement stuff, we're reworking and chiseling away on how they do mixed design, how they specify concrete. And that's been really fun. Give me some really neat stuff that comes out of that. We've been working hard on the tarantula curve for a lot of different things to make that tool an even better mixed design tool, make it a tool that can predict the amount of like the amount of cement you need, the amount of water you need, things like that. So make it like a complete mixed design tool. And that's been awesome and fun. We've got a way to measure curing in real time. So we can measure water content in the fresh concrete kind of as it moves. Okay. That's been really awesome. And our 3D printing is getting better and better all the time. And we're going to 3D print a building this summer on the campus of Oklahoma State University. Now, it's not a massive building. Okay. It's a storage building, but we're going to 3D print a building with ready mixed concrete using large aggregate, 1 inch maximum nominal size aggregate. And we're going to be printing around rebar with a vehicle mounted 3D printer. And I haven't made a lot of YouTube videos about it yet, but don't worry. Yeah, I will. And it's going to be just like the Phoenix you said earlier. Is this new? Oh, it's 5 or 6 years old. We just haven't really told everyone, because I think sometimes you got to be careful. If you start showing people stuff a little bit too early, they'll judge it. Heck, they'll judge it if it's late. Okay. That's what we do, right? We see something and we don't always feel good about change. And so I really want to make sure I have it robust before I bring it out and show it to people and see what's going on. But we talked about my 3D printing on the last podcast that I was on with you. And it's something that we're going to be rolling out big time. And I think it can be practical. I think it can be, are there bumps? There are bumps. Okay. There's always bumps with anything new, but I think it can be practical. I think it's a path to a practical 3D printing method. And I'm going to tell you, I think 3D printing, not for all concrete, no. Okay. But in certain circumstances, I think 3D printing is going to become the way. Okay. I think it will. I'm not here to replace people. Okay. I'm not. I don't think we have enough people out there. All right. I think we need more help. All right. And I think those people are going to keep their jobs, and their jobs are going to be better, and they're going to be better quality, and they're going to be easier for them to execute. Okay. And we don't want to lose any of those people. Okay. Because we don't have enough of them as it is. But I'm not sure we're going to get the large enough volume of new people to reach the same levels that we had before. You know what I mean? Because our work's going up. You know what I mean? We're getting a lot more work to do. And I'm not trying to discourage young people for coming into the concrete industry, because I think you're welcome. There's going to be so much awesome opportunity for you. I'm just saying that this is a tool that can help those people be more efficient as they come into the industry.
Yeah, I agree. We need to leverage some of these new machines to do more with less. So it's just like everything else in our history here, is as technology improves and some jobs do disappear and they just change to different jobs. So I think people are getting over that whole part. I think when the 3D printing and the machine learning, maybe we're still going through that. Everybody's worried about AI taking everybody's jobs, but I think people are starting to recognize, hey, we can improve our quality of work. It's not replacing people or anything. We still need people that work. And like you said, we don't have enough. No, we definitely don't have enough. Tyler, I think this is a good spot to end today. What websites do you want folks to check out on the Phoenix and your websites?
You can check the Phoenix information out at www.concretephoenix.com. You can always check me out on YouTube at youtube.com/Tyler Ley. That's TYLERLEY. And then if you want to learn more about me, you can just go to www.tylerley.com. And those are the three ways that you can probably find me best. I'm on Instagram. I'm on Facebook, not a ton, but some. And I'm trying to make YouTube videos regularly. There's just a lot going on right now, but you're going to see more and more videos. I've got a lot of cool videos planned and being shot and coming out, really cool collaborations coming out. And so make sure you pay attention for that, because you know what? It's cool to be able to find something that you want to explain to someone else and take a 5-minute video that I've made that's like high quality and fun and technically accurate and send it to them and just be like, hey, this is how, finishing works. This is how curing works. This is how whatever works. I've got like 280 of them on there now, all kinds of different topics. And I do that because I think education is our biggest challenge in our industry. And I want to give back, and I want to do what I can to help people move ahead and accomplish their goals and dreams and just make this industry better, man. We have an amazing industry with amazing people, and anything I can do to help them out, man, it's a good day as far as I'm concerned. If I could do that.
Yeah. You're definitely doing your part. I appreciate you coming on the show today, Tyler.
Thank you. And thank you, Seth, for doing what you do, man, and getting the word out and shining light on things that you think are interesting and that people want to hear about. I appreciate you.
Thank you. And that concludes another episode of the Concrete Logic Podcast. I hope you got some value out of that episode and learned a thing or two. If you did, visit our website, concretelogicpodcast.com. Click on the show support tab and learn how you could be listed as a producer of an episode. Again, that's concretelogicpodcast.com. Click on show support tab to learn how you can support the show. And as always, Mike Dunton will take us out.
That alarm always sings couple hours before the sun comes up. Open up the side, put some diesel in the lights and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for $1, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to get that job done with wood,